want to talk about is the convergence of AI and cyber. As you know, given the increasing threat surfaces that we're seeing, whether it's IoT, whether it's a variety of things in our infrastructure, the advances in the digital transformation that we're all talking about, much increased threat surface. And with this increased threat surface, the question is, what do we do about it? One of the tools that we're thinking about using for that is AI. And what we'd like to do during this discussion is have that conversation. What can we do about that? So the first thing we're going to do, I think you're going to enjoy the panel we have, the first thing we're going to do is have our panel just say a little bit about what they do. And then we'll get into some questions about kind of the current state of the art. We're going to talk about research, we're going to talk about workforce and some other interesting issues, all right? So why don't we get started?
Well, hi everyone, I'm Meghan Good, and for 21 years I've been at Leidos leading cyber technology development. My current role is actually leading our internal research and development around cyber AI and software, the confluence of those three areas, and then actually working with external technology partners and figuring out how do we match what we're investing in, what those partners have been working on, into solutions that matter for our customers across defense, the intelligence community, health, and even commercial critical infrastructure.
Thank you.
Hi, good afternoon again. I'm Donald Coulter, and for 2 years I've been at Department of Homeland Security Science and Technology Directorate. Before that I worked for the Army and came from Army Futures Command, where we helped stand up the network cross-functional team, and so I was advised over all of the C5I R&D for the Army for the last few years before coming here, where I'm the Senior Science Advisor for Cybersecurity. So what that just means, I oversee all of our R&D and make sure that it's aligned towards our strategic priorities and working with our partners both within and across all of our Homeland Security enterprise, as well as with industry and academia and all of our federal interagency partners as well, to make sure that we are pushing a cybersecurity research agenda that is fruitful and helps inform the future resilient state of our Homeland Security enterprise.
Well, good afternoon, everybody. My name is David Carroll. I lead the mission engineering portion of the Cybersecurity Directorate for the Cyber and Infrastructure Security Agency, or CISA. So to kind of key in on my DHS S&T colleague here, I make material what they make possible. And our focus is very, very quickly changing to what this panel is going to talk about. My background, actually, it's strange. 10 years at DHS as a MITRE guy. I'm a former DHS chief security architect. Came back after 10 years after Microsoft, Google, and some work in the Navy Reserve over in bad places, and decided I wanted to get back onto the mission full time. I lead a team of about a little over 200 feds and about 1,000 contractors, and we produce little-known things like Einstein, the National Cyber Protection System, the Cyber Analytic Data System, and the Joint Collaborative Environment is our new portfolio. So all the thing, and that is quickly, as you'll hear me speak, going quickly from a NetFlow traditional type of analytic environment where you're sitting there on laptops trying to find the ghost in the machine, to the machine is finding the ghost in the machine, and we are trying to find relevance for it.
Thank you, guys. So let's just start baselining. Where do you think the challenges with cyber are right now that lend themselves to mitigation by AI?
Well, I'll go.
Great question.
It is and anybody who's seen me talk before, it is about collaboration. We need the data. We need to be able to cross that data over, bring it into our national security enterprise, and give that novel information that we are empowered to give. So from my perspective, we could talk program, we could talk funding, we could talk manpower. All those are important, but it all starts and ends for us with data.
So to build on that too, I think AI is especially important as a tool around cyber use cases. From a defensive perspective, I think there's so much to comprehend and so many small pieces coming from lots of different areas that you need more automation. And how we're automating out toil across a workforce that really is already burnt out and that we're trying to continually upskill over time. They need a partner, they need an assistant. It is looking more and more that could come from AI, and particularly generative AI is an exciting opportunity there. But I think the other challenge of that is we're creating a new attack surface, and then we're adding that more in, and that it is about the data, but the challenge is the data too, and about what you can trust, what you can action, and then how fast you can do all of that.
Yeah, I think you alluded to it. You talked about what you can trust. I think one of the key things besides the technology is that human that is still going to be a part of this. So figuring out how do humans interact with these systems, how does having systems that are employing AI affect the way that humans go about participating in the process of defending their systems and making intelligent decisions? How do we assign responsibility for the results of those decisions that are being made between humans and AI teams as well is going to be critical.
So thanks, guys. We've got good setting the stage there. So I want to start with data. So what are your thoughts on how we deal with data? As you know, typically takes 80% of your time to condition the data for these systems. What are your thoughts on dealing with that, as well as, I know you talk about bias and these kinds of things. Let's talk about data, how we can do a better job of working with that data, managing the data, so that we can actually get to the things we need to do as an inference quicker.
Well, I'm trying to influence my teams. We are taking very seriously to the point where my traditional InfoSec team is already pivoting to ML AI ops and SecOps particularly, which is a hard enough thing to go from information assurance, FISMA, FedRAMP, that type of thing, to I need to ensure the data efficacy, the lineage of the data, all the things that to the point where we're having to teach data management, body of knowledge, and things that are really kind of outside the traditional. I mean, they are controls, but they're a different type of controls. And I think that's where we start. I think we also, this venue has talked about zero trust. We have to assume breach in the data. We have to assume that it comes with negative efficacy, and we have to tease that out. But I would also say we also have to be careful. There's a fine line there between teasing out what we think is compromised data and what we are doing to generate bias in the cyber environment, because frankly our job most of the time is to look for that anomaly. And so if we tune it too much, we might miss the anomaly.
And I would say, I think one of the challenges around data is where it is, what's important, when it's important, and for how long, and how to reduce the storage bill of it all. I'm sure others will talk about zero trust later, but I think one of the best gifts of adopting a zero trust philosophy has been gathering more data to make decisions on, and then the downfall is gathering more data to make decisions on, because you have to store it, you have to keep track of it, you have to know what the fields are, you have to know all these ins and outs and what could be right, what could be wrong, and then when you add AI on top of that, it's nice to have labels. It's nice to have things to learn over time. Bias is something to look at, but it really helps when you have a fundamental model of what it actually is and what it isn't. And I think that's one of the big struggles that as we're working with customers and programs, it's where is the data? What is some known knowns in the data? What are the things that you're experiencing that it's new data over time? And how do you manage and get your arms around it? So I actually feel like that's the only growing problem.
Sure.
Yeah, I think this interesting challenge and opportunity with data is that we're collecting so much of it, but we have to be very judicious with how we use it and share it. When I look at it from an R&D perspective, not only we're collecting a lot of operational data, but we have to be able to figure out how can we take some of this and share some of it, or anonymize some of it, or what can we do to it, but that we can use it and share with some of our research partners as well, so that they can not only noodle on it to solve today's problems, but noodle on it to identify those risks of the future. So that's a huge challenge for us.
Megan, you said this quickly, but let's spend a little more time on it. What about data sharing? Because I do know, having been at DHS, that's a challenge, right? So what are some of your thoughts on data sharing? How well we can do a better job of that?
Oh man, it's because I said something pithy backstage.
It's your fault.
All right, well, I actually think data sharing is just hard, which we could probably all agree on. It's choose your hard there. But I think it's what's important to different people at different times. The challenge we have is we like to package up data to be shared, and we like it in PDFs, we like it to be well understood, we want it to be perfect. And that's actually not when it's useful. It's useful in its raw form. It's useful as things to share around, but how do we share something that's interesting and not reshare the whole internet? So it's, again, that balance and that packaging. But I do think there's a lot that we could do better, and would be very intrigued at shared data sets that we have of, and I'm very excited about some of the capabilities that we're coming out with in the different programs to actually share data so that we can come up with interesting models on top of it. And I know there have been a few along these public-private partnerships over time, and would be curious your thoughts, actually, on how those are all going.
I think
Not to put you on the spot, too.
I want to put them on the spot, too. I think that part of what's going to allow us to do a better job of sharing data is continuing to expand on our usage of privacy-preserving technology and privacy-enhancing technologies, and really enabling people to label and identify the provenance of their data and the ownership of their data and be able to tag who or what the types of people and or what types of systems should be able to access that, and being able to encrypt that and protect that in a way that we do have more confidence that we can share this data, which is sensitive to us as a whole, in the aggregate. We can share a portion of this with a partner that shares the mission but doesn't necessarily share a need to have direct access to the raw data as well.
Is this where I'm on the spot?
Yeah.
All right, let's do it. Couple things. I learned a lot. I left in 2012, came back in 10 years later. I learned a lot working in the financial services industry about obfuscation and devaluation of data in $100 billion banks. It's a big deal. I think we, as a federal society, can learn from that and work on it. To the S&T point, I'm a big proponent. I am actually a signer of the homomorphic encryption initial standard at MIT in 2016, I think, if I remember right. I was at Microsoft at the time. So that for those that don't know what that is, that's actually doing calculations and operations and analysis on data while it is encrypted. It is a very interesting technology. We have various things we're working with S&T, oblique queries, things that are going to get us there without having to incur the overhead of too much governance. Because as we both said, that it can become cumbersome and it can become hard to manage, it can become too expensive. And then the last thing I'll say is, we also kind of always have to think about, do we need the data? There's some of us who do, and especially in cyber, and I'll use that. There are some that need it for, for prosecution or for legal reasons or for evidence. There are some folks like us in CISA that need it for analysis. We need to know the pattern. So I've been trying to kind of get folks into understanding, and you've seen this start up in the industry too. We're getting a lot of data, and what's happening is we're starting to turn that into some not so new ideas, like I don't necessarily need all the data and keep it. I need the signal from the data. I need to see the points of reference that go through it. I need to see the pattern. And if you combine that with the AI side, that is really what you're doing, right? You're going there. You're not reading all the data with AI. You're trying to find mechanically that area under the curve and trying to get that efficacy down to where you know that you've got the pattern right. So I think all those things, combined with those advanced technologies coming out, are going to get us there. But it's something we all have to start agreeing on and kind of rallying around, and not snap back into, going too far into the, let's tag and label everything and just hope for the best. It's just not going to work.
It's interesting. Can you guys hear me if I sit back this far? Okay. Sorry?
Better closer.
Better close. Okay. I'm trying to be comfortable. What was interesting is Dave, you brought up homomorphic encryption, but DC, you also mentioned privacy-enhancing, privacy-enabling technologies, right? Thank you for the definition of homomorphic encryption, but DC, could you explain some of the work S&T is doing in this privacy-enhancing work?
Yeah, so homomorphic encryption is one part of our privacy-enhancing research, but we're also looking into different approaches to differential privacy, and as a part of a federated learning opportunity, and that is a difficult challenge, and lots of people have been working on it. But we do think that there have been advances in computing. There's advances in the algorithms. There's advances in the way that we capture and store data, and what these things allow us to do is to do things like protected queries, where you can query on a system without actually telling the system owner what you asked for and why you needed it and what the answer was necessarily. So these are the types of things we're trying to tease out. How do we make it easier and more effective for people to be able to share their data or portions of their data with confidence that only the parts that they want people to have access to they can get.
Great. So let's go back again. Let's go back to kind of first principles. So let's say you have the data, right? What do we think we can accomplish with this? Like, why is this going to make cybersecurity better in some sense? Whoever wants to answer the question.
Oh, I know. I'll go. I tell a story. Listen, my director asked me at some point, what have you, what's good? And I said, well, here's what's interesting. I said, basically, I bent space and time. And she said, what does that mean? And am I going to take your clearance? And I went, no. I said, we took a 44-hour analytic, and we watched as they were processing it, and they were doing all the right data things, everything we've been talking about.
Yep.
But it took 44 hours. And I said, well, what's the commonality here? Well, the commonality was, in that case, they weren't computer scientists, they were threat analysts. And so they were sitting there with their hoodie and their Red Bull, and they were looking at that thing and on that 8-processor Mac. And I said, when I got my data science sheet, it said, what happens if we put 7,500 processors in a containerized environment parallel? Got the same analytic done in 16 minutes. I said, so in cyber, machine, I say it, right now, pretty much take a lot of our regular analytics that aren't too gruesome, and we're at about a 4-hour clip to turn around a novel analytic on it. I keep telling folks, in a year it'll be one day. In 2 to 3 years, it'll have to be instantaneous, because we're fighting against the same thing that we're trying to fix it with. So as the algorithms get faster, and the polymorphism of the malware gets faster, we're going to have to meet it machine on machine at some point. It's essential. We don't have a choice.
So thanks. So DC, I'd like to go to you, because in the green room we talked a little about human-machine teaming, right? So let's pick up from what David said. So what are some of your thoughts on human-machine teaming? People talk about co-pilots, all this kind of stuff. What are some of your thoughts? What's some of the research that's going on?
Okay, so one of the things we're doing in human-machine teaming is we set up a new Action AI Institute with NSF, looking at developing intelligent cyber agents. And so we're building a new AI stack that looks at, first it looks at strategic learning and reasoning for AI agents, then looks at building in human and AI agent collaboration, agent-to-agent, multi-agent collaboration, and strategic game theory, right? But then we intersect that across the cyber life cycle. And so, but that intersection of humans and AI is where we think is the key differentiator in problem space that's going to make a difference on how we use these systems. So one of the things we're doing is working with our social science group to get a better understanding of how do you even measure the efficacy of a cyber operations team. And how do you measure, when you have different players in a team, whether it's just all humans, whether it's all digital agents, or it's a mixture of the two, how do you measure the efficacy of the different players in that game? And then how do you identify opportunities to improve the effectiveness of those folks? So as we develop those measures and understanding of what tweaks and changes we can make to the way we team, and how much information we're sharing with the human, and how much of the decision making we're offloading on the machines, that's an area that we're going to continue to shape and release the literature and understanding and build into the systems that we're not only deploying across DHS and with CISA, but put in open for the public to implement as well.
Thanks. So Megan, you know I was going to turn to you now, right? Yeah. So let's talk about the AI Accelerator, okay? And as you talk about the AI Accelerator, let's talk about trust as well.
Well, so it's the Cyber Accelerator,
Cyber,
right?
my bad.
But as I said, cyber and AI, they go hand in hand. As we've already been talking about, of how do we change from where we are in a rule-based state or writing analytics based on what we saw, what we knew, to how do we look at how that could evolve over time and we can improve our efficacy. And for me, the accelerator that I run is bringing together cyber operators, analysts, technologists, data scientists, and the like, and how do we develop interesting technology that is going to change those systems fundamentally and disrupt the way that we've been doing work. Acceleration for us is about how do we move at speed to get new tech in to solve the challenges that we have today. But with one area that we're really excited about to move on from this rule-based cyber point is that we trust those rules because we wrote them, and because it's based on our knowledge and based on what we saw and what we embedded back in. And there's this whole, it has to be happening that machines are already coming after all of our environments. The proof is there, it's evident, right? The incidents keep happening, and they're getting past the rules, just like teenagers get past your rules, right? And they're very evasive, right? So what we're learning is how to use AI to be evasive teenagers in our systems, and to actually evade the rule sets that we put in place, and then detect that evasion on the other side, and find a way that we can then deploy that with existing systems. And so that's kind of what we've classed as adversarial AI, but it's hard to get to trust. when it's not something that you wrote, when it's not something that you know how it's going to work, when it is something that's evolving and learning over time. And so there's a lot involved there that we've been looking at over the years of how do we measure trust, how do we measure explainability, how do we measure drift in models, how are we starting to look at what the outcomes are. And I love where you're going with the metrics, so what is effective, because that's going to start to prove it. That just adds some more of that trust.
So I'm not gonna let you go on that one, so let's keep going with that. What are you finding instills trust?
So we have an approach that we use called design to trust, and yeah, very clever, right? But I think as a name, though, it's a lot about what are the foundations of trust, and that is about people seeing the technology as it develops over time, as it applies in their environment even more. We have a whole method of where you start just with analysis of data, and you say, what would a model say about this data, then about how do you assist them? What are some recommendations? How do you turn it up to where you're augmenting them and taking some of the work off their shoulders before you're just pressing the autonomous operation button? And so how do you keep dialing different models up that takes away that toil, that automates it away? And so we're finding that through that process, you start to know, well, this is giving me really wonky results. So then what do we have to tune? We are finding right now, because things aren't labeled, to your point, we just have a lot of anomalies, right? And so how do we start tuning to anomalies in real world data? What else do we need to direct to when something isn't working as expected? And I think that builds trust too, of you're not just blindly saying this is the right way. It's how do you keep iterating over time.
DC, can you elaborate more on what you're learning from your social scientists in terms of trust in the metrics?
Absolutely. I think what we're learning is that the way you present information to people matters, and it matters, and you have to be able to tailor that to the person, the individual, right? One system won't fit all. So different people, either whether they're in different roles or even different people in the same role, they still have their own personal preferences for how to interact. One of the things that is actually very important is to build their confidence is being able to believe that if something goes wrong, what can they do to roll those changes back? So not only in the design of the systems up front is thinking about the implementation and the architecture around your implementation. How can you make sure that you build in confidence that, hey, this is how it works. You'll be able to see the results and the impacts of the changes that are being made, either whether they're recommended or even being implemented automatically. But this is an easy button way of how to roll back if you have major concerns with what's happening.
And David, what are you seeing in your environment?
I'll get to the rollback in a second because I run a large DevOps, SRE, MLOps team. So that's an interesting. I can give a practical experience with that. But I think before all that, what I think I'm trying to on another panel, I was asked, do folks have? I just keep saying anybody in this field, has to have a basic data competency.
Yeah.
I think it was in this chair you just saw my CIO at CISA talking. We're big partners in data governance and trying to get the norms around this, right? He's leading that effort. We're working with them on that. I think those are just critical skills. The practical things that folks in the audience might want to do to get started is just start getting that literacy out there, and what you're going to encounter, from the social science perspective is, I really like doing this, and this is just another new thing. So what I've tried to tell folks is it really didn't matter to me. I went through that. We acquired a $100 million AI company at one of my positions, and I disrespected them as the head of data protection and cloud security. I just didn't understand. So I had to roll back, take the time to understand, get educated. I just had a little bit of time on my hands, went to UT, got myself that AI ML backing, and that was painful, but so I empathize. But I just think it's essential. I think if we aren't doing that for our employees, if we aren't giving them those opportunities, if we aren't teaching then all these concepts we're talking about, these tools are going to still become mythical. They're still going to think there's something they're not. And I try to teach it when I teach the classes on it, or I talk to folks. I said it in the green room. I'll say it here. It's math. It's not magic yet. It's not at parity. We aren't up there at where we're talking about things like iRobot or I could go on and on, but we're not there. So I think if we get that started and folks start to normalize it and understand it, and it gets less scary, I think that's when we start to see traction on some of these initiatives. Now, on rollback, it's very important. Canary testing for us, like when we push things out, we push it out through site reliability engineering. We practice everything that any software engineering group would practice. And what that does is it allows us to ease in to these things as we see things and observe as we go along. There's no big bang. There's no, this is IOC, this is FOC, boom. That's a programmatic thing, right? And when you're talking at the scale we're talking about, you have to start and you have to work your way up to it, because that's the only way you're going to see these things, these behaviors, these patterns that we're talking about. And that comes from things, places that we have labels on right now that folks maybe don't pay as much attention to at the leadership side. Your DevOps team, your security operations team, your systems engineering team, the folks who are watching this, who have those placemats that say, yeah, this is what it should look like. And then all of a sudden something goes off, and then the notional thing right now is, oh, well, let's go get data science. That's interesting. No, it's not interesting. It needs to be fixed. It's that type of thing. But without that discipline, so when folks are saying, hey, I want to go from a traditional, I go and I do a big bang to, I'd like to run, agile release, and I'd like to have full stack engineers looking this stuff over and then pushing it out. That is critical, because it's not just because you want those folks to have those great skills and everything. It's because that is the way that you ease into something in any global infrastructure, in any large enterprise.
But
go ahead.
if I could just jump in too, but I think that goes a lot to with R&D and S&T to production, to an operations environment. R&D, it works really great in the lab. And then you keep scaling up, and you keep scaling up and scaling up, and then you need that site reliability engineering. You need that DevOps practice around it. And that, I think, drives adoption as well, of where you're very honest, like, this is R&D, this is a prototype. Yeah. It does great with this kind of protocol and this sort of data, this sort of attacks that we can detect. And knowing the bounds, and then how do you keep incrementally improving it, I think that makes the users then adopt it too, because you went through that. Yeah. You had to go through all the valleys of tears.
Yeah, I think expanding that like MLSecOps pipeline to be inclusive of your development pipeline, your R&D pipeline. You're getting those people talking together, you're getting those systems talking together earlier, and you're thinking through the challenges of how do you share data between those systems, especially when a lot of times they are operating at different levels of like security and sensitivity. You're working through some of those problems that you're already going to have to solve even in the production system anyway, and building those relationships between those people that are going to be involved. So hopefully that's building trust.
I'll add at the end. I go further than that. I want my CRCX teams involved. They are bookends. This is what we were thinking about, and this is what the analytic was supposed to do. Did it really do that on the end? Because you can get into that mode where you're like, I got it done. It's okay. We're good. And then you don't get a feedback loop. And then you wonder why nothing is being, why did we get this data again? What was the operational mission? I don't remember. So that's the only thing I would add is your CRCX teams on both ends, like bookends, just watching that and spinning that in a continuous cycle. It's very valuable.
Let me ask you guys a question, because if I'm seeing the audience, I may have heard what I may have heard if I'm a leader in my organization, that I've got to give many of my people data science creds. What are you guys really saying? What level of education or fluency do you think a user has to have in order to be more comfortable with these tools?
I think there's a whole range, first off.
Sure.
But I do think there's easily available ones from like Coursera and these little nano degrees of data science for dummies. I mean, there's so much out there right now that I think is very easy to consume. I think other ones are even just following things on OpenAI. I actually feel like OpenAI has done a great service to us all of making things very simple to use. But then I think it's all out there. Then at the other side of it, of practitioners, they have to have more in-depth knowledge that's probably traditional education, but that's a whole lot experiential too, and of actually trying things out on these tools. I don't think I have a UT degree in it, though. So.
No, I'm just saying that because it was one of the most painful things. I hate Python. I never want to see another Python again, ever.
But you have a point of view on it, and that's an important competency
I was just saying
builder,
that because,
too.
the thing is, you have to also be empathetic to folks. It was a journey. It was not easy. It was painful. And it wasn't something I was used to. At that point, I wasn't even building things. I was a risk guy. Going, no, you can't do that. This is how it has to be built. And then they look at me and go, we can't use the data that way. If I were to tell you how many times a day I hear that where I work at CISA, well, we got PPNI, or we got PI issues, when maybe they aren't, maybe they're just assumptions, and that goes back to the labeling and everything.
Mm-hmm.
And we say, well, we can't really analyze then because we just don't have access. There's whys in there. And you've got to remember, like the folks who are dealing with that, if they just get something from the privacy office saying, nope, can't do that, then the whole thing just goes off the rails at too early of a stage where you're not actually pushing the envelope a little bit, because the machine's going to push the envelope for you. It doesn't care about your privacy impact assessment. The adversary doesn't care about your rules or your FISMA score. They don't care. And it's essential that we act ethically, we act this way, but it's also, if folks know more about the data, if they know more about how this works, and they're less, I don't even want to say they need to be expert at it, they just need to be less mystified by it. Like the ChatGPT thing, I like to joke around, I'm like, there's a reason why it can't spell things, right? There's a reason why pictures look kind of wonky. I asked it, I'm a Navy officer when I'm not doing this, and I said, hey, could you draw me a picture of an aircraft landing on a carrier? And I got this weird looking flying squirrel thing with wheels that was coming right down on the water. And I'm like, that's interesting. The model has no concept of what that term carrier means in this context. But that got me laughing, like, and you see the mistakes that it makes, and you hear about it on the news, and you say, well, we shouldn't, eat glue. We shouldn't do, but it's essential for folks to have that, because I still tell folks, all my team, I'm like, every one of you sitting there have the bigger cognitive machine. Use it, right? Be deliberative. You're the heuristic machine. You're more powerful. Give them that confidence. Give them that, get that mystification out of there, and let them go to work.
Thanks. We're running out of time, but I do want to touch one more topic. That's adversarial AI. So, Meghan, if you could give us a definition of adversarial AI, and then I'd like you guys to talk about what your concerns and how do you think we can mitigate this.
So I think there's a bit that I referred to as adversarial AI before. There are probably textbook definitions, but my working definition is really, with AI out there, ChatGPT even is a great example. There are ways to manipulate the data to find things around the model, ways to avoid being detected by a model, and ways to actually steal it or replicate it. And so there's a whole host of adversarial techniques being developed to do that. And the thing about adversarial AI for me is that it's very interesting as we're at an adoption point of more and more AI in our systems, and how are we preparing ourselves for that? And I think that really is something that's very easy for us to identify as cyber folks, because we're used to an adversarial domain. We're used to things always being in contest to the defenses that we have, and we have to build our defenses based on that. So exploring adversarial AI in that context makes a lot of sense. And I think for us, what we're doing is making sure that our models that we deploy are actually defensible, that we're actually able to already anticipate that adversarial pressure, and then have ways to be resilient to it.
Yeah, one of the things I'm excited about is, even as we develop our tooling, so for instance, we have a program developing enhanced malware binary analysis and identification capabilities, but as an inherent part of that program, we're using adversarial AI to attack the tool even as it's being developed, to identify some of those flaws or weaknesses or potential vulnerabilities in the resilience of that tool and its efficacy, and finding new holes, or, okay, we developed this, but what could go wrong, and then quickly addressing that, and using AI to identify ways to address that to improve the efficacy of the tool. So I think, including, as we learn more about adversarial uses of AI technology and adversarial attacks against AI-based systems, from a cyber perspective, we're probably at in an advantage because we're always thinking adversarially, but incorporating that not only in our cyber programs, but in our tech-intensive programs in general, just having that adversarial mindset as you develop it, and incorporating that into your program and your development plan is critical.
It is critical. And again, it's always a joke, right? There's the old book, How to Lie with Statistics, and then I just add hyperscale at the end, because that's what we're talking about. Yep. But, when you're talking about, the ghost in the machine, the model, and an attack, yes. To that end, I think one of the things we're really focused on, whether it's AI or not, at least at CISA and at least in my division, is trying to be the what I would say is the as the bellwether for Secure by Design. That's a big initiative at CISA. You're going to see a lot more of me talking with my friend Bob Lord on that, and it's essential that folks understand. To me, it's still basic knowledge, right? We get a lot of requirements. We get, okay, check the box, control, 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 but what does count as adversarial? Because testing sometimes could seem, you won't always get the same results that you think, and some of that is actually good discovery. It's not necessarily adversarial. So, and when it's happening as fast as it's happening in these environments, you can quickly kind of just check the wrong box and let it go, and not know the difference between something that has a necessary effect and maybe is teaching you something, and something, you could kill it too quick, and that's the danger, right? It's a very fine line, and I think it goes way back to, teaching folks that this is a different domain, that we are doing things differently, that compute, IT, whichever way we want to call it, at least in cyber, is evolving into something else, and we've got limited time to get on board with that. It's not coming from cloud, where for most, including myself, took years to get my head around that. This is, the time slice is just tiny compared to that.
Yeah.
Do we have time for a couple of questions? Any questions? Sir.
I'd like to go back to Secure by Design, because I hear a lot of the AI talking about incident response, sort of that attack. What's the other side? Sorry. What about the other side of that? Does AI have anything to play in terms of building systems more securely from the outset?
Of course. At DHS, we've got the big responsible AI initiative, and that trails right down into our cyber focus. Again, if you're not actually observing, we can't just, and I'm just going to speak to government in general, and maybe big integrated on the commercial side too. You can't just offload that and say this is the requirement. You have to have responsible and comprehensive understanding of what it is you're putting out there, and whether that's a model or a system or a program. And so we've just kind of said, okay, well, this is a thing, and it's not a it's been a competency to everybody in the room for years, right? Most of us work in this environment, but to the average person out there, it's just IT. We all deal with that with our families, right? We're just the IT person who does this stuff. And so I think that's the revolution, right? And you'll see things like, secure code, secure binaries. We're going deep on this stuff. Secure models is just another version of that. It's just we have to think in terms of, and tying it into zero trust and everything. We have to think compromise as a practical matter. And just like anything else, the day you put it on the wire, whatever change it is, it's probably on its way to being compromised in one way, shape, or form. So if we get that ideology and we take a breath and we understand that it's always going to be that way, then we start to learn, right, how to get faster and better.
Questions? Sir.
So, yeah, thanks. Really interesting panel. I guess this question would be for Meghan, but really could be for anybody. You've mentioned that having AI in our enterprises adds new attack surface, and I certainly agree with that. But I'd like to know sort of what you think that attack surface is. What are the areas of new risk that deployment of AI brings to us that you're most concerned about or most working on?
Right, great question, Neil. Thank you. So I think with that, there's similar systems, right? It's already deployed. AI gets deployed as software, right? It gets deployed as with data coming in, data coming out, right? And a decision there. So from the actual surface itself, it's not that much of an evolution to what we've already been doing. But I think the struggle becomes what you're doing with the data and the actions that you're taking, the responses going on, and the changes that you might make, which would modify your attack surface very quickly. Are you blocking something? Are you moving something? And I actually am excited about the application of AI and it having that with even deception capabilities, and so what you can change, how you can change your attack surface faster, but add a whole lot more complexity in the mix there. But I think with what I'm seeing is that there's there's just another avenue of a manipulation to the data that then is changing what we do to respond. And there's a bit of it that with learning systems and reinforcement learning that we're deploying, it's happening in ways that we might not be able to explain at scale yet. So I do think there's some uncertainty and a risk factor that's added in as well.
Questions? Sure. Someone's coming around.
As a follow-on to the previous question, thinking about the fact that code assistants have been around for a while, we've been training them for a while. Have we looked at any adversarial poisoning of open source, of Stack Overflow questions, and the other things that the AI coding models have been trained on? If so, what are we doing to kind of mitigate that problem?
Yeah.
Why don't you get started?
That's a big we, right?
Yeah, I mean, you can, I think some of the stuff that's posted on OpenStack is like, even without AI, is already poisoning our software. But yeah.
Not at all.
But I do think that is you're right, that as a major concern is that how are we vetting and validating the type of stuff that's out there, and this really affects a lot of not only the stuff that's like on these websites, but also that's getting pulled into our open source software. So being able to understand like and identify the prevalence, being able to have an ongoing relationship with where did this code come from, where did it get updated, who made changes to it, what does that thing do? I think these generative AI capabilities will continue to get better and better at being able to reason upon and explain what particular codes do, and that we will be able to identify those and see those and make better risk-informed decisions about what to incorporate into the software that we're actually building and using and deploying. But I think that's still a major area of concern that it's always going to be out there. People are going to be poisoned. People are going to be putting fake malicious packages or co-opting packages that were at one time were trusted, but someone forgot to pay their registration and someone else got a hold of it and inserted something malicious there. So I think that's a huge problem that hasn't been solved yet from my perspective. Yeah. Maybe he solved it.
Nope, hasn't been solved. No, but we're working hard, right? And again, there are, folks, there's a balance there too, because the whole purpose of open source is collaboration, is advancement, is ingenuity, right? You don't want to stifle that, but again, I've seen varying levels of this in varying different environments, both commercially and government, where you have to take a rational approach, and so I've seen bastion versions of Git where you bring it in, you scan it, and you make sure. But that, unfortunately, will not survive this next iteration, right? Because it's going to be happening faster than we can get it through those old net locks and balances. So I think we've got a physical problem as far as space and time and how fast we can move against the variability of the AI. And we've also got to understand and respect the philosophical problem. And that goes back to, again, the traditional I put a stamp on it and everything's certified and we're good, changes in the next tenth of a second in this environment. So we have to kind of be practical as well and be respectful of the fact that the whole purpose in doing this is to accept some risk and in the factor of innovation. So it's a hard problem. There's not a silver bullet to that one. I don't know there ever will be.
And I don't know there's one organization that can do it.
It's a community thing.
It's a community, a collective, but then I think the challenge there is what do we each do as part of that, right? And who, you can control your additions to it. You can control what you take from it and how you update it over time. But you're still responsible for that change over time too. It's a challenge.
Well, unfortunately, we're out of time, but I really want to thank wonderful panelists for a great session. Thank you.